everyone, welcome back to the channel. We just completed understanding the feature selection with chi-square method. And why did we use chi-square method? Because over here we had the target feature as categorical and independent feature also we had as categorical. That's why we had to use the chi-square method, because in correlation method we were needed to have the independent features as continuous feature or numeric feature. All right, hope you remember. Now let's think of another situation where we have the target feature as continuous and the independent features as categorical. For sure we cannot perform correlation over here, and because the target feature is also continuous and these are categorical, so we cannot perform the chi-square also. What exactly that we should have the option? We come with this question, and that's where the next analysis, which is ANOVA analysis, comes into the picture. What does ANOVA means? ANOVA means simply analysis of variance, right? So here over here, we just try to understand what is the variance that we are having in different categories, between different categories and within the categories. Now there are two terms which I just threw. First one is what is the variance between categories, and the second one is what is the variance within the categories. What does that mean? If you look at this data, this is loan amount data, loan application data, where loan amount is the target feature and age is the independent feature. So we are trying to establish whether age is having strong relation with loan amount or not. That's what we need to establish. So if we want to perform the ANOVA analysis, what we need to figure out is how many categories are available in age. So like you can see, I have done the binning on age. So if you find, there are 5 categories of age. First, less than 20, then 20 to 30, 30 to 40, 40 to 50, and then 50 plus. Right? So what we need to find is, first we need to find the mean of each of these categories. Then in the first, we need to find the variance between the mean of each of these categories, and then we need to find the variance within each of these categories. Don't worry, I'm just going to explain this thing in very detail one by one. But before that, let's make an hypothesis. Hypothesis is, null hypothesis says that there is no relation between age and loan amount, while the alternate hypothesis says that there is relation between age and loan amount. There is significant relation. And like you already know, if we are talking about the hypothesis, we need to determine a significance level. So this is the significance level I'm going to consider, which is usually used, right? Let's move on. So to proceed further with ANOVA analysis, like I did in the previous video also, I did the video in two parts. In first part, I try to do the calculation of chi-square manually by hand, and then I try to implement the same thing in Python. Same thing I'm going to do over here. If you are not interested in understanding how to perform the ANOVA by hand, you can skip first part of this video and you can continue watching the second half of this video. All right, second half of this video. Let's start with this. If we are performing the ANOVA analysis with hand, there are two things that you need to calculate in the first stage. First one is sum of squares error. Second one is sum of squares between. What does this mean? I'm going to explain one by one. I'll start the second one first. Sum of squares between. What does that mean? Means the mean which you have got for, first of all, you have to find the mean for each of these categories, each of these age category. Then you need to find the grand mean, and then you need to find the difference between grand mean and the mean which you have got for each of these categories. Let me help you understand. Now have a look on this. You see there are 5 categories I have over here: less than 20, 20 to 30, 30 to 40, 40 to 50, and 50 plus. And for each of these category, I have calculated the mean over here. For example, if you see, for less than 20, you have 2 records, 1000 and 2000, right? If you sum them up, it comes to 3000, and if you divide that by 2, you will get 1500. Same goes for rest of the groups also. And this is how we get the mean for each of the categories or groups. And now if you take the mean of this entire all these 5 means, you will get 5500. In the next step, what we need to do is we need to find the difference between this 1500 and this 5500. 1500 minus 5500, if you do, this is what you get, negative 4000. Same thing we need to do for each of the mean. Here we are done with doing all those things. In the next step, you need to find the square of difference. Whatever the difference that you have got, you need to find the square of that, because of the obvious reason, because we want to get rid of this negativity. No, I mean negative or positive things. Okay, that's where we did the square of this. Now after doing the square, next thing which we need to do is we need to find a square of difference multiplied by number of observation in each group. So square of difference was this, and a number of observation in each group, how many number of observations that we had, we need to multiply that. So for example, if you see in the category less than 20, we had 2 records. In each of the category we had 2 records. So what I have done is I have multiplied each of these values in this column with 2, and that's where I got this value. After doing this, I need to sum this up all together. So this is the value which I come up with, and this is exactly what we call sum of squares between. So whatever the difference or variance we are getting between the categories with grand mean, we are doing the square of that, and then we are doing a sum of that. That's what called SSB. Next thing, we're gonna focus on SSE. Now in this, what happens is here we try to find the difference or variance with grand mean, and over here we will try to find the variance with mean of each category and the each individual observation. What does that mean? So let's say what was the mean for the category where age is less than 20? That was 1500. So we're gonna put that over here. Similarly, I have given the mean for each of these categories over here. Next, we are going to find the difference between these two. Means 1000 minus 1500. What we are left with is negative 500. This is what we get. And then the next thing which we are going to do is find the difference of these two, right? Means the difference which we just got, we need to do the square of that, to be honest, okay, to be frank, and then find the sum of that. So this is the sum which we get. We are done with the first stage, SSE and SSB. So SSB is nothing but the variance between the groups. SSE is nothing but the variance within the group. Just keep that in the mind. In the next stage, we are going to find the degree of freedom. In chi-square also, if you remember, we had calculated degree of freedom, and here also we are going to do that. So first we will find degree of freedom within groups. What is the degree of freedom that we have within each of the group? Okay. For that, the formula is number of observation, number of total observation that you have in your data, minus number of groups. So number of total observation which we have is 10, and number of groups, which means categories, that we have is 5. So 10 minus 5 is 5. That's what our degree of freedom within groups. So 5 is the degree of freedom within groups. Now degree of freedom between groups. So for that, the formula is number of groups, which is 5. Here we just found, minus 1. That's it, right? And that we get 4. We are done with finding the degree of freedom as well. Hope you are good with this. Next step, we are going to find the mean square error for this part. All right, for this part within group. And for that, the formula, and we will also find mean of a square between groups also, right? So let's focus on the first one first. So here we simply need to do SSE, which is sum of a square error divided by degree of freedom within group, and that we get 25 lakh divided by 5, which is 5 lakh. Then we need to focus on the second part, which is mean square between MSB, and that is simple, SSB divided by degree of freedom between groups, which will be 8 crores divided by 4, and we come up with approximately 2 crores, right? So we got MSE and we got MSB. This is important thing to calculate the F statistics. With this, we come up with calculating the F statistics, which is nothing but MSB divided by MSE. Guys, the calculation is very simple, right? It's just these steps are multiple. That's where you might find it little confusing. I don't think it's confusing, but if you're getting confused, you can watch the video in slow speed and you can repeat this also. Now let's focus on the calculating F statistics. So to calculate the F statistics, MSB divided by MSE, which is nothing but 2 lakh divided by 5 lakh, and then this is what we get, which is 40. That is the F statistics. Next thing which we need to find is F table value, right? F table value, like in chi-square also, you saw first we find the chi-square calculated value, and then we tried to check the chi-square tabular value. Same way we also need to find the F value by table. So let me just open the Chrome, and here I will try to find the F statistics. F statistics table. All right, here we got this. So significant level alpha value which we had taken was 0.05, if you remember. All right, so this is the next table which we got, and into this df1 is nothing but this degree of freedom between group. This is df1 and this is df2, right? So df1 is 4 for us and df2 is 5. Let's try to find df1 is 4 and df2 is 5, which means this value 5.1922. So this is what I have got. Now what you see over here is F statistics calculated is greater than F statistics tabular, which means the null hypothesis can be rejected. What does that mean? That means alternative hypothesis is true, which means age is having strong relation with loan amount. So that's why we just proven that age is having strong relation with loan amount, and that's where we should make sure that we keep age feature in our model training data. All right, hope this calculation was clear to you. Now let me take you to the Jupyter notebook and help you understand how you can implement and how you can do the feature selection using ANOVA analysis, which is analysis of variance using in Python, right? So first of all, what you need to do is you need to make sure that all of these dependencies are available. All of these dependencies are imported. Next, here I have this data. I'll upload this data on GitHub and I'll share the link with you. Next, we need to first separate the independent features and the target feature. So here I'm going to say features equals to df.drop, and inside that I'm going to say loan amount axis equals to 1, and then target feature is nothing but loan amount. Hope this is clear. Next thing, we need to convert this because these are alphabetic values, right? So I mean the character values, so we need to convert that into the numbers. So for that we are going to do the label encoding, encoded, and this is something I would say pd dot data frame. I'm just creating a blank data frame, nothing else. And for I in df dot columns, here I would say encoded, here I would say I equals to df ali dot fit transform. Now let me show you what is ali. LE is an instance which I have created for label encoder. You see, label encoder I imported from pre-processing sklearn, right? So that is what LE is. Here I'm simply trying to do the label encoding for all of the features, and for that we need to use this method, which is fit transform, and inside that I need to apply the I need to supply the features. Okay, that is it. Let's just see here. Okay, I just missed I over here. All right, there seemed to be some error. Why should be a 1D array? All right, so here I have given the whole data frame, which is not correct. Now what's the problem? Should not have been the problem. Encoded le.fit transform features. Already the mistake which I have made is here I should say features, because we are doing the encoding for the columns available in feature data frame here, right over here. Okay, now that is done. Let's just have a look on this data. Encoded.head. Here is what we got. All right, next thing is split this data into trend test split, and for that I have imported trend test split over here from sklearn model selection module. Okay, now let me just quickly say train test split. Inside that we're gonna say encoded and target. Test size 20%. If you want to get the value exactly same what I have, then you're gonna put this parameter value same as I'm putting, and then the random state you can say 1 to 3 or 42, whatever you want. And over here you're gonna say xtrain, xtest, ytrain, ytest. All right, this is done. Now the next thing is to perform the ANOVA analysis, and for that we have imported over here one more module that is called select k based, right? So let me just try to create an instance for this as well. Select k based. So function which we are going to use is f regression, because here the target feature is continuous, so we would require to use f regression. If this would have been a categorical one, then we would require to use the f classification. Okay, but over here this is the function which we will be using, and this is the method which we are going to try. Select k based. Let me just try to use this select k based. And if you see the parameters here, it asks for score function, right? And let's just apply score function. Score function equals to f underscore regression, and k, they simply ask how many features that you want, out of which you want to find the select best. Okay, and for that what we need to do is, here I will simply say all, and here I can say best features. Best features is the instance created. Then we need to say best features dot fit, and inside that we need to supply our list of features, which we are going to perform on xtrain data. Remember, not on the test data, to avoid the data leakage or overfitting. And here I'm going to put ytrain. All right, so now because this is done, I would store this in a variable. Let's call that selection. Okay, and inside this selection, here I'm going to find scores. You see, this is the score we got for each of the feature, and there will be another thing which is called p-value. This is the p-value which we got. Like we know, lesser the p-value, the better the feature is, and greater the score, better the feature is, right? Scores. So this is what we got. Now let's just put that into a data frame. Okay, pd dot data frame, and over here I'm going to zip three things, which I would say features dot columns. I'm just trying to zip this all together. Okay, features dot columns, and then the next one is I'm simply trying to supply three lists into this. Okay, nothing else. And then I would say selection dot scores, and then the next thing is selection dot p-value. All right, so zip is done, and then I need to supply the columns, and into this column I'm going to say features, then f score, or rather you can say ANOVA score. I'm simply going to say it score, and then p-values. All right, this is done. Selected score, selection score, or let's say ANOVA score. And let's try to print this. All right, this is what we got. Let me just sort it. Sort values by score, ascending equals to false. Bravo, we just got this. Now you see it says age and income are something which are very, very important, and that has high influence on the target feature. So we should consider keeping this, and you can consider dropping these two because these are having higher p-value. So you can feel free to drop these two and you can continue with this. So what does that mean is from X train, in the X train you should keep these two. I mean in X train you should drop these two and keep these two, and in X test also you should perform the same thing. What you should notice is here I perform this ANOVA analysis on X train data only, not on the entire data. But because when you are trying to keep or drop the features, you should do that on both of the data set. And after doing that you train your model and then test the performance of the model. If you want me to do that, just let me know, I'll do that and then I can share that with you. Thank you very much for watching this video. Hope this was very clear. In case of any doubt, do not forget to put that into the comment section. I'll definitely try to help you out. Thanks once again.